Dear students, in our previous class, we have discussed about the stack, what the actual meaning of stack, and how a stack can be represented, the memory representation of stack. It includes two types. One is static representation using arrays. The next one is dynamic representation using linked list. So all these things we have discussed in our previous class. But in our today's class, now we are going to discuss about the creation of stack and then the deletion, creation of stack and adding element to the stack, and deletion of an item from the stack. After that, the operations which are going to be performed using stack. Regarding these things, we are going to discuss in our today's class. First, we shall see how the creation of stack can be done. Creation. I had shown you while representing a stack using one dimensional array. I had shown you. Using linked list. I had shown you. The same way here, a stack can be created. Okay, this can be taken as start. Okay, from here we will take one node. Okay, this is a node. So basically, if we want to add one more node, okay, this is creating stack. Okay, for the stack, if you want to add one more node, then we need to create a new node. Okay, then this node can be added. See here, this is a node. Okay, and this one is new node. Okay, I had shown you by just points. I have drawn the line. Okay, the connection line. Why I have drawn just point? Because this node, a new node, if you want, we can create this node and we can add to the existing stack, already existing stack. We can add that new node later. Okay, so I had shown you through the arrows. Creation means we have created a stack which is contain one node. Okay, if we want more nodes or more elements to be added into the stack, then new element or new node is to be created. After creation, this can be added to the stack. Okay, come, we shall see what this creation explains, how it explains. Okay, after creation, like this, we can create a stack. Okay, now after creating stack, inserting a new node into the stack. How can we insert a new node into the stack? We shall see. Insertion. Insertion. So this is a new node, okay, which is to be inserted here. Okay, like this, and this part could be shaded. So later this can be added here. Okay, this is the node which can be inserted. Okay, the node which is to be inserted is called as new node. This is the already existing stack. What the insertion says now, look. Okay, insertion operation refers to insert and insert an element into the stack. To insert an element, new element is to be created, or this can be called as a new node, and it can be inserted into the stack. Okay, after this, we create a new node. We create a new node and insert okay, an element and insert an element into the stack. Okay, I'll show you how to create start, then one node. Connect this start to node. This includes the creation of stack. Then for this, if you want to add or insert a new element, then we have to create a new node. See, look here. We create a new node, okay, and insert an element into the stack means connect that node into the existing element of the stack. To follow the stack principle, what is that? LIFO, last in, first out. Last in, first out. This is the stack principle. To follow this principle, okay, then what we have to do? We have to create a stack. Then for that stack, we need to add a new element. That is called, this is stack creation. Created a stack using linked list. I am explaining using linked list, not arrays. Okay. Then for insertion, we have to create a new node and we need to add. See here, insertion operation refers to insert an element into the stack. Okay. Insertion refers to inserting an element into the stack. We create a new node. Okay. We will create a new node and insert an element into the stack. Okay, if you want to insert element into the stack, then we need to think this as new element. This new node as completely we can think as element. Okay, and this node can be connected to the existing node of the stack. This is connected to the existing node of the stack. Then it is called as a element is inserted into the stack. Okay, to follow the stack principle. What is the stack principle? That is last in, first out. Okay, at that time, a node need to be created at the end of the linked list. Okay, last in, first out. For this principle, a node is to be created at the last of the linked list. And this element need to be inserted at the last of the linked list. Then if you want to delete, then the last element which is inserted at last, okay, that is to be deleted at first. Okay, this is regarding insertion. Look here, insertion refers to, okay, inserting a new element into the stack. In a stack, if we insert a new element, then that is called as insertion. Okay, so for that, what we will do, we will create a new node to insert an element into the stack. Think this as element, and this can be inserted into the stack. So we will connect this node to the existing node of the stack. It means a new element is created and that element is inserted into the stack by following last in first out. To follow that rule, we will create a new node and we will insert that node into the stack. And if we want to delete, the same thing, the last element which is inserted, that is deleted from the stack. Come, we shall see how can we delete an element. Start. Okay, then node 1, node 2. Okay, take two nodes. This is regarding deletion. Okay, this is start. Okay. Then it is again connected to one more node. If you want to delete a node, then the deletion principle is that the last element which is inserted at last into the stack should be deleted at first. Okay. From this is a linked list. From the linked list, when the last or the topmost node or the topmost element, when we want to delete any element or any node from the linked list or from the stack, then at that time only the element which is inserted at last should be deleted from the stack at first. Okay, this is the rule for deleting an element from the stack. This can be deleted. Okay, we cannot able to delete the middle element. Okay, we cannot able to delete the middle element according to stack rule. If we do like this, then what will happen? Then it will create a big problem. So for that thing, we will not create a middle node or the first node. The node which is inserted at last will be deleted from the stack at first. Okay, this is regarding insertion and deletion of a node from the stack or from the linked list. Now we shall see the operations performed by the stack. Which are the operations performed by stack? There are some operations, okay, as the same way stack is created. If you want to insert an element, we need to create a new element or new node, then it is inserted into the stack. If you want to delete an item, the element or the item or the node which is connected or inserted at the last of linked list or connected to the linked list or inserted in the stack at last should be deleted at first. For that deletion and for creation of stack and for inserting element into the stack, we have some operations. Just like we have discussed the operation regarding one dimensional array and regarding data structures, the operation was what we have discussed. The same thing, stack is also having some operations. We shall see which are the operations of stack. Operations of stack. Okay. The first operation is stack. The first operation is stack. So, what is the use of this stack operation? Look here. It creates, or we can explain it as the operation stack. The operation stack the operation stack creates a new stack. Creates a new stack. And what type of stack it will create? It will create an empty stack. And the stack is empty, and the stack is empty. Okay, then it does not require any parameters. It does not require any parameters. Okay, parameter means it does not require any element to create the stack. Parameter and returns an empty stack. So stack means the operation stack creates a new stack. It will just create a new stack. Okay, just the operation stack will create a new stack which is empty, and it does not require any parameter. Parameter means no elements. To create a stack, nothing is needed. No elements are needed. So finally it will returns to the empty stack. This is about stack operation. Then the second one is push operation. One is stack, the second one is push operation. In bracket, item. Okay, push operation. It inserts an element. It inserts an element into the stack. And an item or an element should be needed. Inserts an element into the stack. We can write it as into top of the stack. Okay, top of the stack, and it needs an item. And returns nothing. Okay, push. Here in bracket itself it has given item. Okay, push means to add an item. Pushing. Okay, just like to push something. Okay, the same way here, pushing an item into the stack. So for that, push operation is used. In bracket, item is already given. It means it inserts an element into the stack. To insert an element into the stack at the top of the stack. Okay, because here there are no elements are there, empty stack. So this can be taken as top. Okay, then this is base. If the stack will full, then this will become the top. Okay, like that. I insert into the stack and it returns nothing. Okay, then the third operation. The third operation is pop. Okay, pop. Third operation is pop. What is the use of this pop? It removes the top item. It removes the top item from the stack. Okay, here this is the top item. If we keep on adding items to the stack, okay, then the element which is at the first will become the top. Okay, if you go on adding the items into the stack, inserting items into the stack, the element or the item which is at the top of the stack will be called as top. Okay, here it removes the top item from the stack. Pop means removing an item from the stack. If you use the pop operation, then the item will be removed, the top item Okay, I have deleted the item number 3. Top item will be removed, and then the remaining item will become the top here. Okay, then it needs no parameters. Okay, no parameters means nothing is needed because we are deleting, and returns returns an item, then here the stack is modified. The stack is modified. See, here removes the top item. I have removed the item. It needs no parameters. Okay, because item is already there in the stack, and returns an item. It will return back. Returns an item. The stack is modified. Modified means here changes are done in the stack because the item has removed from the stack. It means some changes has done in the stack. That is, the stack is modified. Okay, this is regarding third operation. The next operation is peep. P double E P. Sorry, peak it is, not peep, it is peak. Peak. Returns the top item. Returns the top item from the stack. Returns the top item from the stack, but does not remove it. But does not remove it. It returns it needs no parameters. It needs no parameters. No parameters. Then the stack is not modified. The stack is not modified. The stack is not modified. This means returns the top item. It means it will check the items of the stack. Okay, and it will just observe the item which is present in the stack. Okay, but it will not remove that item from the stack. It will just check and returns the top item. Return means it will leave the top item as it is without removing. Okay, that is called returns the top item. Okay, and it will not remove any item. It needs no parameters. It does not require any item because the items are already present in the stack. Then the stack is not modified. This means it will just check the top item of the stack, but it will not remove that item. Here what will happen? No items are needed and no changes are done in the stack. So the stack is finally not modified. Okay, this is called as peak. Next, come to the next operation, that is empty. Is empty. Is empty. Okay, is empty means what this operation will do. This operation will check whether the stack has some elements or the stack is empty. Like that, it will check is empty. Test whether the stack is empty. Test whether the stack is empty. Okay, it means it will check whether the stack has any item, or the stack is empty. Okay, is empty operation is used to check the stack is empty or not. Then later what it will say here, it needs no parameters. Okay, because it is just checking, so it does not need any element or any parameters, and returns a boolean value, it means the number of elements which are present. Okay, it will return that value if present. Okay, otherwise it will return 0. 0 and 1 are the boolean values. If it has any empty, if the stack is not empty, then it will return 1. Okay, if the stack is empty, then it will return 0. That means boolean value. Is empty operation is used to check whether the stack is empty or not. Okay, it does not require any parameters because it is just checking. So after checking, what it will do, it will return a boolean value. If the stack is not empty, then it will return the value 1. If the stack is empty, then it will return the value 0. This is regarding is empty. And the last operation, that is size. The last operation is size. What it will do, returns the number of items, in the stack. Size, checking the size here, 0, 1, 2. It means the total size of the stack is 3 because 3 elements are present here, 0, 1, and 2. Like this, it will check the size of the stack and will return the items of the stack. How many items present in the stack? It will return those number of items. Okay, it means finally size operation is used to check the size of the stacks or the elements which are present in the stack, that how many elements are present. Then after that, it needs no parameters. And returns a integer. Integer means if any numbers are present here, how many elements are present, it will return that values. So finally the size operation is used to check how many number of elements are present into the stack. It means what is the size of the stack. Here the size of the stack is 1, 2, 3, like this. Okay, so it will check the size of the stack and finally it will return an integer. Integer means the size. What is the size of the stack? It will give that number. So this is regarding the operations of the stack. So in our today's class we have discussed the insertion of an element into the linked list or into the stack, then deleting an item from the stack or the linked list. Then finally we have discussed the operations, that is stack, push, pop, peek, is empty, and size. Here the stack operation is used to create a stack, okay, and it does not require any parameters, okay, and it returns an empty stack. That means it will create only the empty stack. Okay, then push operation is used to insert an item into the stack. Okay, it needs an item and it will return nothing. Then pop operation means it is used to remove an item from the stack, remove the top item from the stack. Okay, it does not require any parameters here. the stack will be modified. Modified means some changes are done in the stack. Okay, then peak. This operation is used to check the topmost element of the stack. It does not return any, it does not need any parameters, and it will return nothing here. Okay, then after that, sorry, it will return a boolean value. Then after that, is empty. Is empty stack is used to check whether the stack is empty or not. Okay, if the stack is empty, then it will return 0. So here it will return to boolean value. But in peak operation, okay, the stack is not modified. Okay, I will come to peak operation. Peak operation is used, okay, to check the topmost element of the stack. Okay, after that, after checking, it does not require any parameter for checking because the element is already present in the stack. And here the stack will not be modified because it will not remove any item from the stack. Then come to pop operation. Sorry, is empty operation. Is empty operation is used to check whether the stack is empty or not, and it does not require any parameter. It will return a boolean value. If the stack is empty, it will return 0. If the stack is not empty, then it will return to 1. Then finally, size operation is used to check the items present into the stack. Finally, to check the size of the stack, and it will return the number of items present in the stack. Okay, it does not require any parameters, and after checking, okay, whether the after checking the size of the stack, okay, for checking this, it will not require any parameters, and finally it will give an integer. So the number of elements which are present, it will return that number. So hope you have understood all the operations of the stack. If you have any doubts regarding this, you can ask me personally. Thank you.